Alright, so in this video, we are going to be looking at images in convex mirrors. I'm going to draw a object on this side of the mirror. And what we can already see is that, firstly, it's kind of flipped around from concave mirrors, right? So this time, our focal point and our center of curvature are on the dull side of the mirror, right? So this is the shiny side on the left side. The right side does not reflect light, but since the mirror is curving in this way, our focal point and our center curvature are on the right side rather than the left side. We're actually going to be using very similar rules to the ones that we used before, right? So we have these 4 rules that we've been looking at and that we've been using. We're going to be using the same rules, but slightly modified. So let's take a look at rule number 1. Any ray that goes through the center of curvature will reflect through the center of curvature. What we'll see this time is that we're still going to be aiming our ray of light at this center of curvature. However, it's not going to go through the mirror, right? The mirror is opaque, right? It's not going to let any light through the mirror. And so instead of bouncing through the center of curvature, it will reflect exactly away from the center of curvature, right? So it's a slight modification. So let's see what that looks like in practice. So we have our object, and we have our center of curvature way down here. What we're going to do is our incident ray is going to be towards the center of curvature, and our reflected ray is going to go exactly away from the center of curvature, right? So let me line this again up with the center of curvature, and so it's going to come here, and then it's going to bounce exactly in the opposite direction, right? So this is our reflected ray right here. Now, I'm going to look at rule 2 and see how that gets modified. So rule 2 said that any ray parallel to the principal axis will reflect through the focus. Again, we have the same problem, right? Our ray of light is going to be coming here. It will not go through the mirror. So instead of going through the mirror, it's going to reflect exactly away from the focus, right? So instead of reflecting through the focus, it will reflect away. So let's take our line that is parallel to the principal axis. It's going to come straight across. And then, once it hits the mirror, it's going to reflect directly away from the focal point. Now again, we kind of run into the same problem that we did when we had our object between the vertex and the focus point, in that these rays on the left side of the mirror are never going to intersect. They are never going to cross. And so whenever we see these diverging rays, these rays that are traveling further away from each other, what we need to do is extend the reflected ray back into the object. So in this case, we have our reflected ray, and so all we're going to do is extend it back into the mirror with a dotted line, right? So similar to how we did before when we had our rays diverging, we're going to do the exact same thing into the mirror. And now we're going to do the same thing with our initial image, or sorry, with the image, the ray that we did with our first rule. So we're just going to line this up perfectly with our reflected ray, and then just use dotted lines to extend it back into the mirror. And what we can see is that these rays of light actually intersect right here. And so what this tells us, again, we can look at our salt, is that the size in this case is smaller. The attitude, it is right way up. The location, it's inside the mirror again. and it is between our vertex and our focal point. And the type, we're making this out of dotted lines. There isn't actually real light rays behind this mirror. And so this is a virtual image. One thing to try for yourself is that no matter where you put this object, the salt will always be exactly the same. The salt will never change for convex mirrors. It will always be smaller, right way up, inside the mirror, between the vertex and the focus, and virtual. Okay, so we found the image, and so we're done the problem, but I do want to show you these last two rules just to show you how they apply to a convex mirror. And so if we look at rule number 3, any ray that goes through the focus will reflect parallel to the principal axis. And so this time, we're taking our ray that's coming from the object, and we're aiming at the focus. Now usually this would reflect off in a parallel way, and so this rule does not have to be really modified, right? This ray will not actually go through the focus, right, because it cannot go past the mirror. But when it reflects off, it will reflect off parallel. Let me make sure I have this correct. Okay, and now we're going to do the same thing. We're just going to extend this parallel line back into the object with some dotted lines. And we can see again, thankfully, science works. And it's intersecting in the same place, right? Because again, you could have chosen any two of the rules and got the correct answer. And then for number 4, any ray that hits the vertex will reflect at the same angle that it had with the principal axis. And so this one never changes, right? This rule number 4 requires no modification whatsoever. So all I'm going to do is line up our object and our vertex. And so I want to measure this angle, and then that's the angle that's going to stay the same once it reflects, right? And that's just from the law of reflection. So looking at this, I find that this angle is pretty much exactly 30 degrees. No, sorry, 20 degrees. So that's a 20-degree angle in there. And so I'm just going to put that exact same angle on the other side. And use a ruler to connect it. Draw some arrows. And then same thing, I'm just going to extend this ray, this reflected ray, back into the image, into the mirror. And we see again, it intersects in exactly the same place. Science works, and we're happy.